Welcome back, everybody, or welcome if you're a first-time visitor. For this function, what I want to talk about is finding its max and mins, and more importantly, finding absolute max and mins. That's really what this video is all about, is finding absolutes. How does one find absolute maximum or absolute minimums? Well, what we do is just like we find regular minimums, we take the derivative, 8x plus 8, right? Because power rule, linear rule, derivative of 4x squared is 8x, derivative of 8x is 8. We take our derivative, we set it equal to 0. F prime is equal to 0. That means we're taking 8x plus 8 equal to 0. When you solve that, you get x is negative 1. So you subtract the 8, divide the 8, you get x is negative 1. This is our potential max or min. Now remember, I picked an easy graph so we can kind of visualize it together. 4x squared is a parabola, a U-shaped parabola. It has a vertex. The vertex is at negative 1, okay? Now here's the thing. If I want absolutes, there is an absolute minimum. That would be right there because the way it's angled. Absolute minimum. There wouldn't be an absolute maximum because it goes up forever. Again, I know what 4x squared looks like. It's a parabola pointed up because of my algebra rules. That is the vertex because that's where the minimum will be. There's a minimum in a parabola. It'll be at negative 1. The question is, what if I wanted an absolute max? Could I get one? The answer is, if you force me to. That is, let's say we have part A. What if I said, let's look at the interval from 0 to 3. Let's do that one. What are the absolutes on the interval from 0 to 3? Well, that's interesting to me because I know the graph of this. The graph of this, all right, just a quick sketch in my head. And in fact, I'm going to get rid of this thing here so I can see a graph. The graph of this at negative 1 is our minimum. That's the graph of this. At negative 1 is our minimum because the derivative equal to 0 will find your min and maxes. Since we have a parabola, we only have one extreme. That's the minimum. Now, there's also, if I plug 0 into this function, I get its y-intercept. I'm curious where it crosses the y-axis. If I plug in 0, I get the y-intercept at negative 10. So at 0, so here's negative 1. At 0, we'd be at negative 10. Just give me another point to plot. When I plug in 0, I'm at negative 10. So what I see is my minimums at negative 1, my graph goes up from there. If I take this graph and focus on this interval, 0 to 3, that's on this piece of the graph. What I'm looking for is if I take and just look at the interval from 0 to 3, what do I see? Well, the parabola here is down here at negative 10. And it just climbs. Well, how far does it climb? I can plug in 3 and see how far it climbs. When I plug in 3, well, 3, so I'm plugging in 3. When I plug in 3, I get 9 times 4, 36. I get 36 and 24. 36 and 24, what is that? 36, 24, that's 60. Minus 10 is 50. I notice when I plug in 3, I've climbed up to the height of 50. I start out at the height of negative 10, and I climb to the height of 50. And I have this part of the graph. What I've done for part A is I'm looking at, well, first of all, in general, let's slow down. These are one of these types of questions where if you go too fast, you'll miss. For the function, this is a parabola. When you take its derivative, set equal to 0, you get one critical point. It happens to be a minimum because a parabola looks like this, and the only thing you would find is the minimum. That's the minimum. The graph is always concave up. I'm restricting us, though, on the interval from 0 to 3. You always got to read your questions. Where are you restricted? I'm restricted on the interval from 0 to 3. Since I'm restricted on the interval from 0 to 3, that negative 1 really doesn't mean anything. That negative 1 is not useful for me. If I'm restricting my interval from 0 to 3, that's like this part of the graph, and I just blew it up a little bit, and zoomed in on it. When I plug 0 into the function, I get negative 10. When I plug 3 into the function, hopefully I didn't make a mistake there, 9 times 4 is 36, 36 is 24 is 60, minus 10 is 50. So there's my graph. Again, imagine the parabola starting here and coming up. I'm only focusing on this range. When I focus on this domain, notice my minimum is no longer -1. My absolute minimum, look at the graph. Where's the lowest point right now? The lowest point is -10. That is the absolute minimum on this region. On this region, from 0 to 3, the minimum is -10. On this region, so here's your minimum right now, -10. And here's your maximum, 50. When somebody gives me an interval, what they're really doing is chopping a piece of this graph and zooming in. And when you zoom in on a piece of the graph, you change what the calculus does. By calculus, the absolute minimum was -1, but you're not looking at that portion. You're looking at a more restrictive portion from 0 to 3. On that portion, that's the minimum. At 0 is the minimum, and the maximum is at 3. What I'm trying to say is, if somebody gives you restrictions, you have to do your derivative analysis. You have to do that. You got to do your derivative analysis. But please check your endpoints. Please check your endpoints, because they may be the answers. Let's look at another one to kind of back this up. But let me get an interval now that contains that minimum. See, I did one with a sneaky, right? I did not contain. That's important. Sometimes you don't contain your absolute that you have in the previous work. There's -1. Let's say I did the interval -2 to 0. Okay, I did that interval now. -2 to 0. So what does that mean? Well, if I focus on my picture, -2 to 0, that's a really bad shade there. I'm going to care about this side of the graph more. We know, again, at 0, it's -10, so we're down here. We know at -11, or actually we don't know, at -1. I said -11, don't know why. At -1, I don't know the actual y value. About to find it. When I plug in -1, what do we get, guys? Well, when you plug in -1, please be careful of the parentheses here. It's a parentheses -1, so that's actually 4. That's a -8. That's a -10. 4 minus 8 is -4. Minus 10 is -14. We're actually way down at -14 here. This is -10. So I have this point, I have this point, and then there's the -2, the left-hand endpoint of the interval. Now, it may be a -2 due to symmetry. It doesn't have to be. I always, if I'm doing in a range, and I'm looking at absolutes over range, that's the key. What I do is I take a look at the endpoints. I plot the endpoints. Always plot the endpoints. How do you plot the endpoints? Take your endpoints, plug them in to get their y's. I plug 0 in, I got -10. I plug -2 in, well, let's check it out now. -2 squared is 4. 4 times 4 is 16. 16 minus 16 is 0, and that gives me a -10. So yes, I already should have known that. Due to symmetry, they would have been there because it took a symmetric interval around the parabola. Neither here nor there. This is where I've zoomed in now. So what I did in my grand poobah picture is I cut it at this little base. And I said, let's focus in on that little base right there. Because you know, it's all about the base. Definitely no treble. So what we're doing here is I want to graph just this restricted interval, -2 to 0. There it is. What do I notice about this? Well, there clearly is a minimum. There it is. The minimum is -14. If the question was, what is the minimum over this interval? It's -14 over this interval. That's what we're looking at, is absolute max and mins on an interval. So be careful. Always look at your intervals. Now we actually have matching maxes. Okay. The matching maxes are the endpoints here. Both endpoints are maximums because look at the graph. You don't get higher than -10, and -10 is achieved at both endpoints. Do they always have to be the same height? No. If I had picked -3, that would have given us, well, it would have been higher. That would have given us a different number, and that would have been the max. Please review one more time. If I want absolute max or min, so let's breathe and pause for just a second. Okay, to find absolutes, what do? You first got to take the derivative so you can isolate any potential max or mins. And there you go. There is a minimum. How do I know there's a minimum? I looked at the graph of this. It's a parabola, so that's a minimum. The previous one, part A, I didn't have it on there, so I'd be careful. Part B, the minimum's actually in this interval, so I knew I had the minimum picked easily at -1, -14. The maximum, check your endpoints. Check your endpoints, both -2 and 0. These are endpoints. How do you check them? Plug them in. Plug them in. I hate to say it, that's what you got to do. Plug them in and give a quick sketch to give you an idea of where your absolute mins and max are. When you have a restricted interval, it's very good chance you're going to have an absolute max or min. You just got to do this exhaustive search. You have to take the derivative, analyze it, and you have to check the endpoints to make sure your max or min is not at an endpoint, or maybe it is. Thank you guys for watching this video. Hope you enjoyed it.